Okay, so let's dig into this. When you're, driving your daily commute maybe, or that long road trip, do you ever like stop and think about what actually goes into designing the road itself?
Hmm. Probably not often enough.
Right. We notice the curves, maybe the smoothness or lack of it. But what about something really fundamental like how thick that pavement needs to be to handle all the traffic?
Yeah, it's really key, isn't it? And something most of us, well, we just take it completely for granted. But getting that thickness right, it depends on this really surprisingly complex understanding of the traffic. Not just, how many cars today, but what kind of vehicles and how many will there be years down the line? And crucially, how much damage are they actually doing?
And that right there, that's exactly what we're doing a deep dive into today. We're looking at how engineers calculate this vital traffic data, the data that, well, supports the whole road design, especially figuring out, yeah, that pavement thickness.
Exactly. And we're working from the sources you sent over, which they really lay out the steps and all the factors involved pretty meticulously.
Right. So our mission really is to unpack all of this, understand the key numbers, the forecasts they talk about, and see why getting this stuff right is just so important for the roads we use every single day.
Hmm.
Because it's definitely more than just like counting cars passing by, right? It sounds like predicting the future and even quantifying wear and tear.
Oh, absolutely. And what's really interesting is how this whole detailed process, it directly shapes the lifespan of our roads.
Yeah.
How often they need fixing. The main reason we need this data, things your sources call CVPD, commercial vehicles per day, and the overall traffic rate, it's all for designing roads properly, making them durable.
Okay, CVPD. I noticed the sources really zero in on commercial vehicles. Why the special focus on trucks and buses?
Well, simply put, they're the heavy hitters. Your sources really stress this. Commercial vehicles, especially the ones with heavy axles, they cause way more damage to the pavement than regular passenger cars, like disproportionately more.
Okay, that makes sense.
So understanding their numbers, their impact, it's just critical for the road's structure. These calculations, guided by standards the sources mention the IRC method, specifically IRC .37 down 2018, they're essential. They tell engineers how thick the pavement needs to be to handle the expected load over its whole life.
Right, so it's not just about today's traffic, it's about the total cumulative load, the sort of total beating the road's going to take over maybe decades.
Precisely. That's the goal. Calculating what's called design traffic. It's this really crucial number, represents the cumulative number of standard axles expected over the road's entire planned lifespan. Think of it as the total workload the pavement must endure.
Cumulative standard axles. Okay, sounds a bit technical. But I see the formula they highlight. Design traffic, CVPD, times a growth factor, times the design period, times something called VDF. Okay, let's break that down. CVPD, commercial vehicles per day. How do they even get that initial number for right now?
That comes from some pretty fundamental groundwork. Traffic volume count and classification. Engineers go out, they do surveys at specific spots, count the vehicles, and this is key, classify them. Separate out the commercial ones, the trucks, the buses. That count over a set time, usually a day, gives you your starting CVPD for that spot.
Got it. So that's the snapshot of today. But roads, they're meant to last, what, 10, 15, maybe 20 years plus? Traffic's not going to stay static. That's where this growth factor comes in, I guess.
Absolutely. Yeah, you just can't design a road that lasts using only today's traffic numbers. It wouldn't work. The traffic growth factor, that's, well, probably one of the trickiest parts. It's an estimate, right? It accounts for how much they expect traffic volume to increase each year over the road's lifespan.
And the design period. That seems simpler.
That one is, yeah, it's just the number of years the road is designed for, defined by the project specs.
Okay. And VDF, vehicle damage factor. The sources seem to really emphasize this one. What's it actually quantifying?
Right. This is super important. The vehicle damage factor, VDF. Your sources really nail this. It basically measures the relative damage different types of vehicles, or more accurately, different axle loads due to the pavement. I mean, think about it. One heavy axle on a big, fully loaded truck, it can cause the same amount of pavement damage as literally thousands of passenger cars.
Wow. Thousands. Okay, that really highlights why VDF is so critical then.
Exactly. So the VDF takes that mix of vehicles you counted in your CVPD survey, all the different trucks and buses, and it converts their impact into an equivalent number of standard axles. It's like a benchmark unit defined to those design guidelines, like IRC 27. It lets engineers compare the total expected load in a consistent way, whether it's mostly small vans or, massive haul trucks.
Okay, that makes a lot of sense. So the formula ties it all together. You start with today's commercial traffic, CVPD, project how it'll grow using the growth factor over the design period, and then adjust for the actual damage using the VDF. And that gives you the total expected punishment, the design traffic.
You got it. That's the process. And like you said, figuring out that growth factor, that feels the most like trying to, well, predict the future.
So how do they go about predicting future traffic? The sources must talk about this. It can't just be a guess, right?
No, it's definitely not guesswork. It relies, as your sources detail, pretty heavily on analyzing historical data and then applying forecasting methods. The first step, the absolute foundation, is gather historical data. This means finding consistent traffic volume data over several years, and crucially from the same location or maybe a very similar road nearby.
Consistency is key then.
Absolutely.
Okay.
You need traffic surveys done over time, or maybe reports from government transport departments, data from those automated counters you sometimes see. Same methods, same place. That's how you spot a reliable trend.
Right. Need a solid picture of the past to project forward.
Exactly. So once you have that historical data compiled, you then determine the initial and final traffic counts for the period you're looking at.
Yeah.
Your sources give a good, clear example. Let's say traffic was 5,000 vehicles a day back in 2015, and then measured again at the same spot in 2025, it's 7,500 vehicles a day.
Okay.
That gives you your start and end points over a time period of, in this case, 10 years.
And then you use a formula they provide to get the growth rate. I see it here. It's final traffic divided by initial traffic, then raised to the power of 1 divided by time period, then subtract 1.
Yep, that's the one. It calculates the compound annual growth rate over that historical stretch. So using their numbers, 7,500, 5,000, that whole thing raised to the power of 110, and then subtract 1.
Okay, let me see. That comes out to 0.0414.
Right, which you then multiply by 100 to get the percentage.
4.14% per year. So based only on that history, 2015 to 2025, traffic grew on average 4.14% annually.
Yeah, correct. But, and this is a big but, your sources are very clear on this, that historical calculation is just a starting point, a baseline. It's not enough on its own. You absolutely have to consider external factors, things that could change future growth compared to the past trend.
Ah, okay. Things that maybe weren't fully in play in the past data, but might affect traffic going forward.
Well, exactly. Things like overall population growth in the area. More people usually means more trips, more deliveries. Economic development is a huge one. Are there plans for new factories, big shopping centers? Changes in local industry, that can massively boost commercial traffic.
Right, a new industrial park would change things?
Definitely. And major infrastructure changes themselves. Building a new highway nearby, extending a train line, adding a bridge. These could totally shift traffic patterns. Sometimes they draw traffic away from the road you're designing. Sometimes they funnel more traffic onto it.
Okay, so you calculate this rate from the past, but then you have to kind of adjust it based on forecasts for these external things. That sounds like it adds a lot of complexity. And maybe some uncertainty.
It really does. Which leads to the final, very important step, validation. You need to check your calculated growth rate, the one you've adjusted for those future factors against other sources. Compare it with, say, regional trends, official government forecasts, maybe wider transport studies, just to make sure it seems realistic,
Sanity check it, basically.
Exactly.
Yeah.
And your sources also mention adjusting for predictable seasonal variations, like big holiday traffic spikes. You need to make sure your initial data wasn't collected during some unusual peak or lull.
Okay, so it's historical data, a formula, plus forecasting economic and population shifts. Wow, where do engineers actually find all this stuff? The historical counts, the forecasts, the regional trends. Sounds like a huge data hunt.
It can be, yeah. But thankfully, there are established places to look, which your materials point out. Government agencies are usually the first stop. National and regional transport departments. The sources mention MWorth in India, the FHWA in the U.S., the DFT in the U.K. as examples. They collect and often publish loads of traffic data, sometimes going back decades.
Makes sense. They manage the roads. They should have the data.
Right. Then you have specialized traffic analytics platforms. Companies like TomTom Traffic Stats, they offer historical data on things like congestion, traffic flow patterns. And platforms like DataRaid, they actually aggregate and sell different data sets, including traffic and mobility info.
I even saw Google Maps mentioned as a potential source. That surprised me a bit.
Yeah, it's interesting, isn't it? Tools that use data from navigation services, like maybe looking at aggregated, anonymized historical trends. From Google Maps, traffic data, they can offer insights that might not show up in the traditional roadside counts. And obviously, research institutions and universities, they often do long-term transport studies, and that work is often publicly available.
And there were private data providers listed too, like NRX, Here Technologies, OpenStreetMap.
Yeah, it really shows that getting the full picture for that design traffic calculation, it means pulling info from lots of different streams, official stats, commercial data, academic research, even data coming from the tech we use every day to get around.
Okay, let's bring this back home for the listener. Why does all this matter? All this complexity, the formulas, the data digging, the forecasting. Why should you care when you're just driving?
Oh, it matters hugely because it directly impacts your experience, your safety, the reliability of the roads you use. Getting this design traffic calculation right, it lets engineers design the actual road structure, the pavement thickness, the layers underneath to the proper standard, like those IRC .37 guidelines mentioned.
And if they get it wrong, if they underestimate.
Well, if the design traffic is too low, the pavement just won't be strong enough for the real traffic load over its life. It'll break down way faster than planned. You'll see more potholes, more cracks.
More road work, more delays.
Exactly. Frequent disruptive repairs, rougher rides, maybe even safety problems eventually.
And if they overestimate,
then you're basically wasting money, often public money, on building an overly thick, over-engineered road that didn't need to be quite so robust. So getting it right means you get a road that lasts as long as it's supposed to. It means a smoother, safer drive, fewer inconvenient repairs, and a road that's actually built for the traffic it needs to carry now and in the future. It connects all those abstract numbers and forecasts directly to the concrete under your tires.
right, it really translates from spreadsheets and reports into how the road actually feels and performs. Okay, so let's quickly recap them based on the sources. Designing roads that last, especially getting that pavement thickness right, it really hinges on these complex traffic calculations. You need the current commercial traffic count, CVPD. You need to project its growth using historical data and formulas, but also factor in those external things, population, economy, other infrastructure. Then you quantify the actual damage different vehicles do using the VDF, and you have to pull all this data together from lots of places. Government, researchers, private companies, even navigation tech.
Yeah, it's this intricate mix, isn't it? Surveying, digging through history, math, forecasting socioeconomic trends, and really understanding the physics of how vehicles wear down pavement.
It definitely gives you a new appreciation for just how much thought goes into something we see as simple as asphalt. Which leads me to a final thought, just based only on what we've discussed. You know, the reliance on calculated growth rates from the past, the potential for big, unforeseen external changes that are really just forecasts, and needing data from all these different sources, maybe some aren't perfect. Considering all that, how much does this complexity in predicting future traffic, how much does it make road design feel maybe less like an exact science and more like, I don't know, an ongoing experiment, even with all the tools and standards?
That's a really interesting question. That interplay between historical data, complex formulas, and, yes, the inherent uncertainty of forecasting future conditions. It certainly raises questions about just how precise we can ultimately be in designing for decades ahead.
Something to think about maybe next time you're out on the road, cruising along smoothly, or maybe bouncing over a patch that, well, perhaps didn't quite anticipate everything that was coming.
Indeed. Food for thought.